Hello, everybody, again. So, straight on to the next talk by Jeremiah Paige. You are sharing your code wrong and what to do about it. Jeremiah is a professional code twiddler, and apparently computers work better after he's twiddled, so that's pretty impressive. So, welcome, Jeremiah. Thank you.
Thank you. Yes, I'm here to tell you how you're sharing your code wrong, or at least maybe how you are. But before we all get average today, I hope to show you, if you are sharing it wrong, how you can identify it and what we can do to make it better. So it's a little bit of an eye-catching, title to get you maybe sitting in the seats here, but I'll move on from this kind of big statement to another one. And that is, I think if you write code, you share code. Everyone who writes any code is already sharing it. And I think I'm safe to say that everyone out here today writes some amount of code. It's probably why you chose to attend a coding conference on your weekend. So I maintain that everyone out here today is already sharing code. And if everyone is, then there's a chance that at least a couple of you are sharing it maybe less than optimally. Maybe you're not completely convinced yet. You say, I don't share code. I'm not there yet. I'm not ready. That's why I'm here today. Maybe you never post your code online for others, whether for collaboration or just to let people see it. Maybe you attend conferences, but you don't actually share any code with anyone there. It's possible. Maybe none of your coworkers. Maybe they're not technical. Maybe you're not right now in a technical role. Okay. None of your friends are interested in this. But there's one person that we all share code with, and that's ourselves. If you've ever gone to make your code installable, you're sharing your code with yourself or whoever does the install. Likewise, if you use a task automation framework that takes care of setting up virtual environments, tearing them down, installing your code, it's just another way to install your code, even though it hides it behind the scenes. If you do automation of any kind in the cloud, locally, on your own server, you're sharing code. Equally, if you deploy, even if you deploy in Docker, you're sharing your code into the container to get it running. Just as I tried to show on the last slide that sharing code doesn't actually involve two people, it often does, but it can just be you. Sharing your code doesn't require multiple machines. Your code can stay on the same machine you wrote it, and you're still sharing it. So, if my assertion is true that everyone here is sharing code already, my question to you is, how are you already sharing your code? If you're already doing it, how do you take the code that you took a long time and perfected to get the job done in your dev environment, but that's not where it needs to run. It needs to run somewhere else. So how do you package that up in a way that it still works where you need it to? Let's say that I have some code I want to share with you. It doesn't particularly matter what it does, but how do I share it with you? I guess I'm sharing it with you right now. It's right there. You could copy it down into an interactive Python session. You could come find slides later and copy-paste it somewhere. But, that's kind of ridiculous, right? We usually save Python as files, so I give it a good file name and the good .py ending. And so now I can give you a file. Great. What do you do with that file? You probably don't leave it in a downloads folder. You move it into an environment, a virtual environment. Were you supposed to make a new virtual environment for this file or reuse an existing one? Does it matter if you put it into a conda environment or not? All I've done is just give you a file. I haven't given you the ability to completely recreate the development environment. But sure, you can be explicit with Python, tell it exactly where you saved that file, and Python will run it. So that works. I gave you a file, you figured out how to run it, and it works. Except you can't import from any location on your computer, so if you wanted to use this as a library, you would have to first move there. Now you can use this file as either an executable or a library. So yeah, I guess it's working. But there's one thing I didn't tell you yet. To use this code that I wrote, you also need URLib3 and GeoPy. Now I happen to actually remember what versions you need, so that's helpful. But this is just more information I'm dumping on you. What do you do if I tell you you need urlib 3? Presumably what I meant to tell you was that you should pip install urlib 3 and GeoPy into the same Python environment that you're going to use to run my code. Sure. Or was it pip install? Or if you conda installed or used a conda environment, do you need to conda install? Again, kind of, we're used to recording information like this in files. And so I can share with you Python file and requirements.txt file. Hand you both things, and maybe you know how to make that work, or maybe I can guide you through it. But as time goes on and I develop my application and I grow it, and I split out work into multiple modules, now it's 4 files for the next person who I want to share this with. I just hand you 4 things, and maybe I just assume you know that you have to save all the Python files together. And the requirements has to be installed. Does it need to be saved next to the Python files or somewhere else? I don't know, it doesn't matter. So maybe one day I want to make this easier for the next person, so I zip it up. Now again, I get to hand out one thing to you, and you can reuse this code. And zip files are a nice, easy way to transport things, and they work well with Python. If you stick this full zip path on your Python path, you could actually import this code, and I wouldn't even have to tell you how to unzip it. It'll just work right out of the file. That's really cool. I didn't have to explain how to unzip or how to drag and drop these Python files into a virtual environment. But this only works as long as the zip file is always on Python path. So now maybe instead of instructing you how you can put these Python files in the right place on your file system, I now have to explain how to edit a bash RC or a zish RC such that Python path is always up to date. Well, maybe I say I don't want to do that, so I just tell you always use the sys.path.append. That'll always work, as long as the zip file never moves, or you never try to use this on a different machine that doesn't have this folder. These are all ways of sharing code, and I've seen them all used in real life. I've used many of them to share code. They all can get the job done, but they all kind of fall down at some point. You forget to add it to Python path, so you add it to sys.path.append. You forgot to install the requirements.txt. Well, you remember next time. They all kind of get you most of the way there, good enough that it works in the next spot. But it doesn't work that first time you forget to add it to Python path. Well, so you add it to Python path, but you forgot to add the other thing to Python path that it needs to import. Or when you were developing the application, you used relative imports, which is something only packages can do. And then you copy-pasted some files somewhere else, and it's no longer a package. And all of a sudden, these things don't work. You can't just start dotting around the file system with your imports. It doesn't work like that. And so far, I've kind of just been concentrated on me. Someone wants to use my code. I'm kind of excited about that, so I say, here it is. I put it on a file. I put it on a screen. I sent it to you. Go make it work. And I haven't really stopped to think about how that process is finished when it gets to where it needs to go. So there's another party involved in sharing code, sometimes yourself, but the other end of this experience is unwrapping your code. Sharing your code from where you wrote it involves wrapping it up into ideally the smallest package you can. Then you put that code where it needs to actually run, and then you have to unwrap it. This is the process of sharing code. But these aren't individual, distinct steps that can be completely isolated from each other. It's kind of a whole process. And when you spend no time caring about the wrapping, you just send 2 files over the wire and hope that they work when they get there, then you make the other end, the unwrapping story, much harder. Your user has to do a lot more debugging, they have to have a lot more implicit knowledge. Whereas if you take the time to wrap up your code carefully, include all the details about your environment, and deliver it to your user in a nice way, then the unwrapping story can be much easier and much less error-prone. Sort of the more technical pipeline of sharing code is the full packaging story, where you package, distribute, and install. Now, what I think is most important about sharing code is that what you users want the most is to run your code. Seems like a very obvious statement on the face of it. But what I mean is, once you convince someone that they want to use your code, or they come to you and they say, this fixes a problem that I need solved, as soon as they decide to take on the burden of bringing in outside code to their project, the next thing they'd like to do is start running that code to fix their problem. What they don't want to do is come to your project, forget the problem they're trying to solve, instead scroll through multiple pages of install instructions, get confused, run into some bugs, and walk away because nothing worked. Your users don't really care how you decide to wrap up your code or how you say it should be installed. They don't care about the decisions you're going to have to make for packaging. All they want to do is have your code run for them. The only time they care about the decisions you make about packaging is when it stops them, it frustrates them, it gives them errors, it causes them to become confused. Now, you might not really care about packaging or doing things the right way either, but if you want to share code and get it all the way from the one party to the other, someone has to care about these problems. So anyone that you don't think about is a problem that still exists, it just exists for your users. All right, so the best sharing strategy is the one that works the first time, every time. Another very obvious on the face of it statement. Who doesn't want their code to run every time they try it? But this is obviously an ideal state. We can't have code that runs successfully the first time, every time, for every user on every system, no matter the circumstances. So we want to adopt strategies that get us as close to this as we can. First strategy is to reduce the number of steps that are required to share your code. Less steps there are, less things there are to go wrong. The next is I would encourage you to reduce any choices for your users, any decision points in your installation instructions, your sharing instructions. If you give your user a choice, you're not only asking them to spend more mental effort installing your code, you're also giving them the option to choose the wrong thing. Maybe they just don't know, or they don't have enough information to make the right answer, so they pick one, and it's wrong. The last strategy I would use is similar to not giving users decisions. Don't give them complicated tools or complicated processes. They don't want to think about how to install. Your favorite packaging tools might be Make and Auto tools. But if you're sharing Python code, those are probably unfamiliar to a lot of your audience. And asking them to learn a brand new tool just to get your code is a big barrier to them. Following best practices is a good idea, not just because they're called best practices, but because they represent inertia and sort of community knowledge around these processes and these tasks. So if you ask someone to pip install something, if they've ever coded in Python before, they're probably familiar with that. They have experience. They've debugged bad pip installs in the past. They can go to people that aren't you, like a forum or a blog post, to solve their problems. Okay, so I was trying to share this code earlier, and this was kind of as far as I got. So I had 2 files, and I gave them to you, and I said, you can figure this out, right? Well, can we do better? Can I do better? Instead of 2 files, I could probably share just 1 file. I need that Python code to work, so I guess I'll just stick the information into a comment. And now, I asked you to install these things before, but can I get away with asking you to install nothing and still have this work? Some of you might see where this is going. This is actually a pretty new packaging standard accepted by the Python Packaging Authority called inline metadata. You can put this kind of comment in your scripts, and any tool that recognizes the comment will be able to run your code without you doing anything. You don't have to install anything, you don't have to prepare a virtual environment, you don't even have to have the right Python in some cases. So if you pass that single file exactly as I wrote it to any of these tools, it'll just work. They'll run it. It doesn't matter where you saved the file, what your currently active Python is, what your currently active virtual environment is. It just works the way it's supposed to. So that's a really easy sharing strategy, I think. I gave you no decisions, one file, and it just works every time. But I am kind of hiding a little complexity in the sharing story in that if you're not familiar with any of these tools, you now must stop and go, what is this tool? How do I install it? Because I maybe don't have it yet. Also, you have to check the version because the standard is so new, it's only been out 1 year, that if you have this tool already but it's a too old of a version, it won't know what to do with it anyways. So this can be a very simple sharing strategy, but only if you and the receiver are familiar with these tools already. And also by design, inline metadata works with one file. So it doesn't give us space to grow the application. So in order to grow, I'm going to have to take my individual Python files and my requirements.txt and restructure it on the file system, lay it out like a Python package, which involves a couple very specific files and a little bit of necessary structure in the directories. So every Python project has a pyproject.toml, and that'll capture all of our environment information. So in our case, requirements, but it can capture other things too. And every pyproject.toml can be associated with either just one Python file or one directory of Python files. And to be a Python project, every directory containing Python files has to have an under init under.py. It doesn't have to contain anything, you just have to have one in every directory. All right, my last attempt. It went pretty well, but I want it to get bigger. So I'm going to have to leave the inline script behind, and I'm going to break the file in half again. The dependencies line from inline metadata to toml doesn't change at all. It just moves into a new file, and it moves under the project header. So this captures all the same information that I had in my inline metadata and in my earlier attempt with the requirements.txt. But this is not a proper Python package yet. We need a little more information in the toml file for it to be to spec. I also have to give my project a name and a version so that the thing I build has a name and a version, which just makes it easier to share and install. And the last piece of data you have to have in your toml is a new table, build system. Now, build systems in Python are often confusing and always frustrating. You have to have a build system in your pyproject.toml to be a package. But there is no default build system, not really. And all the ones that exist in the world are third party. By that I mean the core Python language doesn't come with one. So you have to go and decide which one you want to use, and you have to write it down exactly. That requires is a package, and the build backend is a string that you just have to specify that is unique to that project. Now, I'll tell you for pure Python projects, even complex ones, as long as you're not doing any weird cross-language or highly system-specific coding, it doesn't matter what build system you choose. It really doesn't. They all do exactly the same thing. They all work great with pure Python files. So you kind of just got to pick one and stick with it. If you've ever used one before, keep using it. If someone recommends a new one, go ahead and try it. They're all going to work. I showed earlier that Hatch, the tool, can run inline metadata scripts. It comes with a backend, so I just reused it here. So moving on from build system rant. We are back to having two files, or I am back to having two files. Basically represents the same information, but exactly as it was just written, this is a proper Python package. It is recognized as something that can be built by UV, pip, build, conda. They all recognize this as a Python package. And now I've laid the groundwork. I can start growing my project. This is what was happening earlier, as I was starting to get too many Python files. Except this isn't a Python project anymore, because a toml file can only be associated with one file. So I have to stuff it into a directory. And now this is actually still not a Python project, because I forgot. You have to have that init file in there. All right, so a lot more files, right? I was trying to just add 2 modules. I ended up having to make 3 and a directory. And this seems like a much harder sharing story. Like I've just complicated everything. Well, it's a lot of work up front, and we're not even to the sharing part yet. None of this is wrapping my code. This has all been prep work so that my code can get more complex. Even though I've added a lot more Python files, the toml file actually didn't have to change at all. Once I got that initial definition down, it gets to stay just as it is, as long as my dependencies don't change. I can reorganize my Python code however I want, and it's still a package. So, once it's a proper package, I can build it. Using any build tool that recognizes Python code, we'll be able to take that directory structure and turn it into one file, a wheel. And one file is what we've been after. So Hatch works, but also any other build tool will be able to recognize it. It doesn't have to be the one that matches your backend. And wheel is basically the de facto standard for sharing Python code across the universe. So it gives you a lot of possibility. You know, it's the best we can do. I don't know how to share code without sharing at least one file. So one file, and I can share one script, but I can also share a multi-file executable. I can share a pure library or a plugin system. Anything that can be defined by Python code, or even some things that involve not Python code, can be delivered through a wheel. And a wheel gives the receiver a lot of power. Because you're using a community standard wheel that everyone recognizes and is not tied to any one tool, your instructions might helpfully say, go ahead and pip install this wheel. And the receiver could do that, but they could also UV install it, or conda install it, or do whatever they want. And if they want to use a different tool than what you recommended, they don't have to tell you about it. They don't have to ask you to package your code in a new, unique way. You gave them a standard, and they get to interoperate with it however they want. So this is a really good sharing strategy. We have migrated all the way to a full Python package. But I started this talk by sort of putting out there that everyone here is already sharing code. So if you're already sharing code, not using packaging, and it's working for you, why would you go through any of this effort? It's a lot of work, it's usually confusing, frustrating, and it's not one time. The upfront cost is big, but it's continual ongoing maintenance effort to maintain a package. So why would I ask you to put any of this effort in if you already have a sharing strategy? Well, the process, as I described earlier, is that whenever you want to share code, you wrap it up, you deliver it, you unwrap it. And that's true. But that's true for a single share. If you want to share it with 5 different machines, or with 20 different people, or if you have 2,000 downloads from pypy.org, You are still wrapping your code exactly once, but now you are, through the magic of software, redistributing it however many times, but everyone has to unwrap it. So any work you put in to making the wrapping nicer, less error-prone when it's installed, less confusing, you're saving time and errors, often for yourself, who is your biggest user of your code, for anyone who installs it. And you never have to rewrap it again until you make a new version of your software. Thank you.